a laser to measure the thickness of a hair?
What? That makes no sense.
Yep. You see, when light goes through a small opening, it bends around the edges, and parts of the light wave interfere with each other and make a cool pattern.
Oh, like when you hold your fingers really close together and look at a light?
Exactly.
So how does it help us measure a hair?
Well, the size of the pattern is related to the size of the hair. We can measure the pattern, and if we know the wavelength of the laser, we can figure out how wide the hair is.
Okay, well, how do we do that?
Well, first, we need to tape a hair over the aperture of the laser pointer. Be careful to keep the laser off while you do this. Then point the laser at the wall, and maybe tape a piece of paper to the wall for a screen.
And then we turn on the laser.
Right. Turn on the laser and look at the pattern on the screen.
Well, that's weird. There's light from the laser, but it's separated out by all these dark splotches and patches and stuff.
Yeah, that's called a diffraction pattern. We need to measure the size of the brightest line in the center. We'll mark its edges with a pencil, putting the marks in the centers of the dark spots on either side.
Okay, we can put the paper on the table and make the measurement with a ruler. The middle spot is 1.6 centimeters long. Don't we also need to know how far the laser is from the screen?
Yes, we'll measure that with a tape measure. It's 1 meter from the end of the laser to the paper. And then the last thing we need is the wavelength of the laser.
It's easy. It says right here on the side of the laser, 650 nanometers. So what do we do with all this information?
We can find the diameter of a hair using this formula.
Wow!
It's not so bad once you try it. D is the diameter of the hair. That's what we want to find. X is the distance from the hair to the screen, 1 meter. And Y is the length of that middle line in the diffraction pattern, from the dark spot on one side to the dark spot on the other. You said that was 1.6 centimeters.
Wow, that's a lot of math.
But it works out. I get that the hair is about 125 times bigger than the wavelength of light. That's 81,000 nanometers, or 81 micrometers. That's about right, because the average hair is between 60 and 100 micrometers thick.
Well, that's tiny, but waves of this red light are even tinier. If 125 of them would fit across the diameter of this hair. Wow.
I'm Lydia.
And I'm Catherine.
And this was Exploring Diffraction.